No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
Sir, we can't hear you.
Are you hearing me now?
Yes,
Yes,
sir. Now.
Yes, sir.
কিন্তু স্যার অনেক কথা বেজে বেজে আসছে।
Is there any
Sir,
noise?
no, sir.
Is there any noise? Hello, students.
No, sir.
এখন কি পরিষ্কার শোনা যাচ্ছে?
Yes, sir.
Yes, sir.
Yeah, loud and clear, right?
Yes, sir. Loud and clear, sir.
Yes, sir. Loud and clear.
What is happening? I don't know. What is the problem? I don't know, but it seems my microphone is not working properly. Okay, so let's start the class. Do you have any quiz today? Oh,
Yes, sir.
Yes,
Yes, sir.
oh my God,
Yes,
I
sir.
forgot. Okay, no problem. No problem. I will share you the question a little bit later. So let me give you the question first. Wait a second. Wait a second. Take a paper. Everyone, please take a paper. Write your name, ID on the paper. Also the subject and section. So write your subject, section, name, ID, those things. Am I audible? Students. Hello, students. Are you
Yes,
hearing
sir.
me?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So take a paper. Write your name. First of all, write down the subject. Then your name, your ID. Okay. So on the top of the paper, just write down these things. At least take 2 papers. Take 2 papers, and the paper should be something like this. Take 2 papers, okay?
Sir, A4 size paper.
Yeah, A4 paper, right? So let me share you the question. The problem যেটা হয়েছে actually, you know, আমি বলেছিলাম কিনা জানি না, কিন্তু তোমাদেরকে বলছি ভাষা চেঞ্জের কথা। Have I informed you? Not probably.
No, sir.
The thing is, I am shifting my home. I'm shifting my home on 1st October. I'm so busy about organizing everything because I'm the only child of my I'm the only male child of my parents, so it's depend on me. So I'm organizing everything, and after the classes, when I go to the home, I become so busy that I forgot everything. I forgot everything about your class, your quiz, and everything. It's very bad, you know. really
Sir,
really bad.
তাহলে
Yeah.
স্যার নেক্সট
তাহলে
নেক্সট দিন
weekend
এক্সামটা
answer.
নিলে স্যার
No,
Sir,
sir.
next in
We should not be we should not be delayed. Already I have delayed one more. Already I have delayed the class. It would be very bad example. So let me share you the question. The question will be extremely simple. Don't worry. So just wait a second. What could I give you? What could I give you? What could be the question? এর আগের দিন চিন্তা করছিলাম যে ওকে লেটস গিভ দ্য থিওরি, বাট অল দ্য থিওরিজ আর রিটেন, there is no meaning of giving the thing because এটা অ্যাকচুয়ালি কিছু কাজ কিছু হবে না, রাইট? আর কি দিতে পারি? সো ম্যাথস যেগুলো আছে, ম্যাথস গুলো তো অ্যাকচুয়ালি এক্সট্রিমলি সিম্পল, ইজ নট ইট? এবং ভ্যারিয়েশন অফ দোজ ম্যাথস আর, I mean the formulas are definitely same, so I'm not getting the idea what should I do. So what could be the question? Write down the question.
স্যার এটা কি স্যার ডাবল এম মিটার দিছেন ডিজিট না দিয়ে?
Yeah, double A. আমি দিচ্ছি, ডিজিট গুলো ফাঁকা রেখে যাও। হ্যাঁ, আমি দিচ্ছি।
ঠিক আছে স্যার।
স্যার কোশ্চেনটাকে তুলে দিব স্যার?
হ্যাঁ হ্যাঁ, তুলতে থাকো, ফাঁকা ফাঁকা রেখে তুলো। ডাবল এ গুলো ফাঁকা রেখে তুলো, আমি ভ্যালু দিচ্ছি। দেখা যাচ্ছে তো নাকি?
ইয়েস স্যার।
have you written these things?
Yes, sir.
সেটু বাকি আছে।
জি স্যার লিখে ফেলছি।
সবাই কোশ্চেনটা লিখো। আজকে 5 মার্কস এর একটা কুইজ নিব, ঠিক আছে? 5 মার্কস অনলি। তো এইটা তো অলরেডি আছে, তাই না? এই 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 ম্যাথটা
Yes,
তো
sir.
সলভ করে দেওয়াই আছে। তো তাহলে কি করতে হবে? এটাকে টুইস্ট আনতে হবে, তাই তো? টুইস্টটা কিভাবে আনবো? তো সবাই নিশ্চয়ই এই জিনিসটা সম্পর্কে জানো, তাই না? এটা কি জিনিস এটা জানো তো নিশ্চয়ই।
Sir, ID.
স্যার আইডি।
আইডি স্যার।
তাহলে এক কাজ করো, তোমরা হচ্ছে এটাকে A5 এটাকে A6 করে নাও, আর এটাকে A8 আর এটাকে A2 করে নাও। Just, ঠিক আছে? বুঝতে পারলা?
জি জি স্যার বুঝতে পারছি।
সেম থিং, জাস্ট এখানে যার যার আইডি নাম্বার
স্যার
অনুযায়ী প্রথমে
গুণাকারে
নো
A5
নাম্বার
A6 কি
no
গুণাকারে?
no no not multiplication, only the number. Suppose 1 2 3 5 6 7 তার মানে এই হিসাবে, মানে এটার হিসাবে A5 A6 as per this one, A5 A6 কত হবে বলো তো? 56, ঠিক আছে? এই হিসাবে
ইয়েস স্যার।
তারপরে A8 A2 A8 A2 এটা কত হবে বলো? 82, got it? তোমরা ধরতে পারছো তো? এটা জাস্ট
Yes,
তোমাদের
sir.
ইয়ে করতে হবে, সংখ্যাগুলো নিতে হবে, এই আর কিছু না। A8 A2, কিন্তু সবার জন্য কিন্তু সেম হবে না, এটা কিন্তু ডিফারেন্ট হবে। ঠিক আছে, কতক্ষণ সময় লাগবে বলো? 2:14 বাজে, 2:30-এর মধ্যে শেষ করে দেবা, 15 মিনিটস ম্যাক্স।
স্যার আই থিঙ্ক মনে হচ্ছে সবারই 8 and 2 সেম।
ও হ্যাঁ, তাই তো, ভালো তো, ভালো কথা বলছো তো। রাইট 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 রাইট। হবে না, তাহলে হবে না, তাহলে খেলা যাবে না। তো মেক ইট A7, মেক ইট A7 A5 or A4। এবার সেম হলে অসুবিধা নেই, যা হবে হবে। মেক ইট A7 A4। তো 15 minutes, time is 15 minutes, okay?
স্যার
Time is
সেন্টিমিটারটা কত স্যার একটু বলবেন?
up to 2:30, কি করবো?
স্যার সেন্টিমিটারেরটা কত স্যার, মানে ডাবল এ?
এটা বুঝি নাই।
স্যার একটা মিটারে আছে আর একটা মানে কন্ডাক্টরটা কত স্যার?
কিসের কন্ডাক্টর? সব দেওয়া আছে তো, সেন্টিমিটারে দেওয়া। অবশ্য অনেক বেশি হয়ে যায় না সেন্টিমিটারের ভ্যালুটা? মিলিমিটারে করি তাহলে নাকি? এটা মিলিমিটারে দাও, এটা বেশি হয়ে যাচ্ছে অনেক।
স্যার সেন্টিমিটার স্যার ঠিক আছে আমারটা স্যার, শুধু 4 আসে স্যার।
না, অনেক বেশি হবে। অনেকের জন্য ঠিক আছে, কিন্তু অনেকের জন্য অনেক বেশি হয়ে যাবে। ওকে, করো, যা হয় হবে, করো। প্রসেসটা বুঝতে পারলেই হলো। আর আমি লিংক শেয়ার করে দিচ্ছি,
মিটারে করবো না স্যার সেন্টিমিটার দিয়ে করবো স্যার?
যেটা কোশ্চেন দেওয়া আছে সেটা দিয়ে করবো। আমি কোশ্চেনে যা দিয়েছি সেটা দিয়ে করবো, আর কিছু এক্সট্রা কিছু করতে হবে না। হ্যাঁ, ডু ইট ডু ইট। Time should not be extended. Time will not be extended, so please be careful about the time. Time will not be extended.
স্যার কন্ডাক্টরকে দুইটা কন্ডাক্টরের জন্য বের করতে হবে নাকি একটার জন্য বের করবো?
যেটা তুমি জানো। দেখো কোয়েশ্চেন পড়ো, মুখস্থ কিছু করো না, খালি এটাই বলবো। কোয়েশ্চেন যা আছে সেটা অ্যান্সার দাও।
স্যার স্যার
স্যার,
স্যার আমার তো A5 আর A6 এর গুণফল স্যার 0 আছে।
তোমাকে তো
স্যার
গুণ
লন
করতে কেউ
0
বলে
করলে
নাই।
তো স্যার
কোথায় গুণ করতে
ইরর
বলো?
আসে।
আমি তোমাকে গুণ করতে বলছি নাকি? এটা তো শুধু নাম্বার নিতে হবে।
জি স্যার, দুইটা
5 আর
নাম্বার।
5 আর 6 গুণ করলে তো 30 হতো, আমি কি 30 লিখছি? তুমি
ওকে
দেখে
স্যার,
লিখছো না?
সরি স্যার।
Do you get the link? Do you get the link? Do you get the link for question answer upload? Yes or no?
Yes, sir.
স্যার পিডিএফ দিতে হবে নাকি পিকচার দিলে হবে?
This is 227. So you have 3 minutes to submit. Hurry up.
পিডিএফ দিব স্যার।
Yeah, you can submit PDF or image, but only one file can be submitted.
স্যার অনেকক্ষণ ধরে আপলোড করতে চাচ্ছি স্যার, কিন্তু আপলোড হচ্ছে না। হ্যালো স্যার।
So we are going to start the class now.
স্যার আমি স্যার মানে স্যার আগে 2:13 আগে থেকে স্যার দিচ্ছি, কিন্তু স্যার নিচ্ছে না।
So I cannot give you the solution for that issue. I'm sorry to say that.
আমারও স্যার বলতেছে স্যার লো মেমোরি স্যার।
স্যার আমি অনেক আগেই স্যার দিচ্ছি, কিন্তু স্যার
That's
যায় না।
from your computer, or that is the problem of your internet. So I cannot solve that issue. Sorry. So now we are going to start the new topic. The name of the topic is capacitance of the transmission line. So far we studied about the inductance of the transmission line. Now we are going to talk about the capacitance of the transmission line. So do you need a break now, or can we start? Do you need a break now or later?
ব্রেক দিলে স্যার ভালো হতো স্যার 5 মিনিটের জন্য।
Sure.
স্যার তা না হলে স্যার আজকে মানে ক্লাসটা স্যার টানা করিয়ে স্যার লাস্টে তাড়াতাড়ি ছুটি দিয়ে দিন স্যার, তাইলে হবে স্যার।
তাড়াতাড়ি ছুটি দেওয়ার কোনো অপশন নেই, সরি। So let's take a break up to 2:40, but then we will start the class. Okay.
Sir, can I just send the picture to you, sir? Chat in the chat, sir.
No, sir. can you start the class now, Tanvir? May you start the
Yes, sir.
class?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So those who are present, please raise your hand. Those who are in the class, please raise your hand. Those who are hearing me, please raise your hand. So, from our basic knowledge of capacitor, you know, if two plates are separated with a dielectric material, and if we just apply a voltage difference across these two metal bodies, what would happen? The charges will be stored, and the whole device is known as the capacitor. So inside these two metal sheets, there should be dielectric material. Is not it? Could you
Yes, sir.
remember the construction of the capacitor? So
Yes,
what is
sir.
the construction? The construction is extremely simple. Two metal sheets. Inside the metal sheets, there should be dielectric material. What is the dielectric material? Dielectric material is basically kind of insulator
Current not flow.
through which current cannot flow. But another property is magnetic flux can flow. That is, magnetic flux can flow through the dielectric material, but it will act like the insulator or current can't flow. So this kind of material is called the dielectric material. Like if you think about the air, through the air, you know it very well, current cannot flow, is not it? Can the current flow through the air? Actually, no. But what about the flux? Flux can flow, is not it? So magnetic flux can flow, but current cannot flow through the air. So it is the dielectric material. Now just consider the long transmission line which is hanging from the pole. So suppose this is the wire number 1 and this is the pole you just consider. Okay. So from the pole, basically that is the wire number 1 and there is another wire which is hanging. Okay. So through these cables, suppose just think about it's a single phase 2 wire line. Just consider single phase 2 wire line. How many phases? Single phase 2 wire line. How many wires are there? Basically, two wires are there. Huh? So what would happen? These two these two these two cables. This is the cable number 1 and the cable number 2. These are metallic cables through which currents can flow, right? Now consider this is the high potential cable, this is the low potential cable. Inside this high potential and low potential cable, there is the air gap, is not it? So
Yes, sir.
this transmission line, should not it act like the capacitor? You understand? So though it is not a capacitor, but there will be some capacitance. There will be some virtual capacitance. Do you understand? What is the meaning of virtual? Virtual is definitely which has no physical existence. So the virtual capacitance exists in transmission line. Could you understand?
Yes, sir.
Yes, sir.
So that is the reason of capacitance and reason of starting the capacitance. I hope you can understand the basic concept, how the capacitance is grown and why we need to think about that. Now, this capacitance is negligible if we think per meter. If I think about 1 meter length of transmission line, then definitely this amount is negligible. But if you think about thousands of kilometers of transmission line, in such a case, this capacitance value will be definitely a very big number. And therefore, we need to think of this capacitance effect. Is that clear for everyone?
Yes.
Now the capacitance, I hope you can remember the simple formula was epsilon A divided by D. And another formula was C is equals to Q divided by V. Could you remember these two formulas, students?
Yes, sir.
So from here, I hope you can also understand V should be equals to Q divided by C. Is not it? And
Yes.
we can also write down this is Q divided by epsilon A divided by D. Am I correct?
Yes, sir.
Okay. Now try to understand if I want to find out the capacitance of a wire which has the resistance of, which has the radius of R. What is the radius? Radius is R. So what will be the A? Cross-sectional area. It must be pi R square, is not it?
Yes, sir.
Cross-sectional area should be pi R square. Now consider this is the cable A, and through the cable A, QA amount of charge is flowing. How much charge is flowing? This is the amount of charge flowing through the cable A. Okay. Now from the cable A at X distance, we want to check the amount of capacitance. Rakibul, why you are late? So once again, from the cable A with the distance of X, we want to check the amount of capacitance. So that should be our target. So now let's calculate. I hope you can understand this line because this is the equation coming up from here. E is equals to E means basically voltage, QA for AQA divided by epsilon naught. Basically, epsilon is equals to epsilon R into epsilon naught. For metallic material, actually epsilon R is very, very, very near to 1. So we can just say epsilon is equals to epsilon naught. Okay, so we got epsilon naught and 2 pi x. Why it is 2 pi x? Just consider the cross-sectional area or the distance x actually. So we need to think about the circumference, that is the 2 pi x. So ultimately what we find out? We find out QA is the charge per meter of length, epsilon naught is the permittivity of the free space. So this is the equation of E. Now if we think about the voltage of the terminal of the cable A, what should be the value? We need to integrate from R to infinite, R to infinity. That is capacitance will be grown after the radius. So the lowest amount is R. It could be infinite distance away. So it is infinite QA divided by twice pi x epsilon naught. Now if we just integrate it, what do we get? QA divided by twice by epsilon naught is the constant over here. We get it as 1 by x dx, right? So what else we can find out? Now just consider capacitors of a single phase 2-wire line. Basically that was for a single line, normal only one cable. But if you think about a single phase 2-wire line, then what would happen? First of all, we need to think about R for R to infinity. that is R to infinity is for the first cable, that is for the cable number 1, and then for the cable number 2. So for the cable number 2, it's a 2-wire line. You know, if it is a 2-wire line, if I just consider the current is flowing from right to left in the wire number 1, then in the second wire, the current will flow from left to right. Is not it? If you think about the charge flow means electron flow. We say current is the flow of electron. What is current? Current is flow of electrons. That is our concept, flow of electrons or flow of charges. So current is the flow of electron. If current flows, suppose on the left side, we have the power stations. On the left side is the power station. On the right side, the domestic users. So what should be the direction of current? The current will flow from power station to the domestic users, but what will be the flow of electron? Electron will flow on the opposite direction, is not it? Do you remember? Current flows from high voltage to low voltage. Current flows from high voltage to low voltage. But what about the electrons? Electrons are basically attracted by the positive terminals. Therefore, the electrons will move from the users towards the source. Am I right, sir?
Yes,
So
sir.
that will happen for
Yes,
the
sir.
positive words. That will happen for the positive words. What would be the thing happening in the neutral words? If you think about the neutral wire, then what will happen? In the neutral wire, the electrons must be reversed back. If the electrons do not go reversely to the user, then what would happen? The material will be changed because each and every material has a particular amount of electrons. So even I know electron doesn't flow, but even if I think electron flows, we need to understand that electron will flow back to the source where it is coming up. Otherwise, the materials will be easily changed, right? So anyway, just consider the cable number A. Through the cable number A, Q amount of charge is flowing, and if it is plus Q, then on the other cable number B, it must be minus Q. That is, if you think about the direction of current on this one through to the surface, then here it would be reverse. We need to understand that the current is coming out of the surface. So anyway, the distance between them is the D. So what we are finding out, we are finding out the voltage difference here. So the voltage difference, what we want to find out is the C is equals to, we have written already, C is equals to epsilon A divided by D, and C is equals to Q divided by V, or V is equals to Q divided by C. And from here, we have already found out Q is equals Q divided by epsilon A divided by D. So from here, what we get? We get, for the first one, the total phase difference between the cable number 1 and cable number 2, the total phase difference should be, for the first cable, we need to consider R to infinity. For the second cable, we need to understand that the nearest distance is the D and the farthest distance is the infinity, and the direction of current is opposite, therefore the negative sign. So then if we just calculate what we get, if we just put down the limit, 1 by x is ln x. So ln x, if we just put down the limits and do the calculation, our result is becoming VA is equals to Q divided by twice by epsilon ln D divided by R volts. Okay. So the total phase difference between conductor P, in the similar way, you can write down minus Q divided by twice by epsilon ln D divided by R. Previously it was plus, now it is minus. Okay. Now what we need to do, when we find out the phase voltage difference is VA minus VB. Have to think about the voltage difference. Voltage difference is VA minus VB. So voltage difference is VA minus VB. So VA is this much, Q divided by twice by epsilon ln D divided by R. VB is minus Q divided by twice by epsilon ln D divided by R. So VA minus VB is the VAB, which can also be said the 2VA. So ultimately, we get 2 multiplied by Q divided by 2 pi epsilon naught. And ultimately what we get VAB, basically 2 cancels each other, right? So 2 is cancelling each other. So capacitance between, we found out the VAB, that is voltage difference between point A and point B. Now we want to find out the CAB. What is the CAB? You know C is equals to Q divided by VAB, right? So as because CAB is equals to Q divided by VAB, we know the VAB, there is the Q, so Q cancels each other, 2 cancel each other, and lastly, the equation is becoming pi epsilon naught divided by ln D divided by R F per M. What is the F per M? Anyone? What is the F per M? Faraday per
meter.
So Faraday per
capacitance. It is becoming this much Faraday per meter. Okay. Now let's do a very simple math. So what it is saying? Any question from here?
No, sir.
Any question here? Please tell me.
No, sir.
স্যার হ্যালো স্যার
Any confusion?
স্যার আমি তো স্যার হচ্ছে এখানে এ পয়েন্ট থেকে স্যার বি পয়েন্টে হচ্ছে বের করলাম স্যার। আমি যদি স্যার এটা উল্টা করতাম, মানে বি পয়েন্ট থেকে হচ্ছে এ পয়েন্টের জন্য বের করবো, তখন স্যার কি হতো স্যার?
Capacitance value will be same. CAB, you can say VAB. তখন যেটা হতো, if you think about the CBA, then you need to find out the VBA. Simple as that. But the value of the capacitance will be same. The value will be same. But the problem is, no, direction is not the issue. The issue is, if you think about the capacitor is a bipolar device, right? We need to think about the polarity of the capacitor. So the polarity must be fixed for any capacitor. So in a transmission line, the first wire, through the first wire, we are assuming what is the charge? Charge is plus Q. And for the second wire, what is the charge? Charge is minus Q. Or we can just say it is the reverse direction. So if it is positive, if it is considered positive, compared with the positive, it is negative. So we need to understand the VAB. We are considering that VA is greater than VB. Is not it? VA means VA minus VB, and we are assuming that VA is greater than VB. How it is greater than? If you say, so one is carrying the positive charge, so for that positive charge, the voltage will be positive, and another one is carrying the negative charge, therefore the voltage will be negative. But the amounts are same. The voltage of the first wire and the second wire, the voltages are same. Therefore, we have written VAB is equals to twice the VA. The voltage value are same, but there is a voltage difference. The voltage difference will be twice the voltage difference of the first one. We have written VAB is equal to twice the VA, and after doing the calculation, we got this result. Is that clear?
Yes, sir.
জি স্যার, বুঝতে পারছি।
Okay. Now let's do this example. What it is saying, a single phase transmission line has 2 parallel conductors 3 meters away, 3 meters apart, radius of each conductor being 1 centimeter. The same math which we have done previously, right? A few minutes ago, but in that math we calculated the inductance. Now it is asking for calculating the capacitance, is not it?
Yes, sir. Yes, sir.
Okay. So which formula we need to use?
So perhaps we need the radius of the wire, so it is 1 centimeter. The spacing of the conductors is 300 centimeter. So the capacitance of the line should be pi epsilon naught divided by ln d by r Faraday per meter. So if we just put down all the values, the result is becoming this much. 0.4875 10 to the power minus 2 microfarad per kilometer. This much microfarad per kilometer. Now, if you think about a transmission line of 200 kilometers long, what would be the capacitance? For 1200 kilometer long transmission line, what would be the capacitance? Can you just tell me?
স্যার 1200 ইনটু 10 কিউব দিয়ে স্যার জাস্ট গুণ করে দিব স্যার যে অ্যান্সারটা আমি পেয়েছি।
Tell me the result. Give me the result, please. Someone please calculate and give me the result.
স্যার 5850 ফেরার আসে স্যার।
So,
স্যার অ্যান্সার স্যার আসে হচ্ছে স্যার 5850
5850, then
স্যার মাইক্রো ফেরার স্যার।
5850 microfarad per meter. Microfarad. Is it?
জি স্যার।
Everyone. Please do the calculation, everyone. Don't sit idle. Please work because it is important. What I am going to teach you, it is important. Hello, students. Is the result accurate?
Sir, 5.85 microfarad.
Someone is saying 585 microfarad. So,
Yes, sir. 5.85, sir.
so is it 5.84? 5.8. Everyone, please check and tell me. If you don't do these things, you will be asleep, right? You'll start sleeping the class. Please do it. These things are
Sir, 1.49 into 10 to the power minus 12.
microfarad. Okay, this is 5.85 microfarad. That's the capacitance. Now that's the capacitance. So what will happen for the XC? You know the XC 1 by 2 pi FC. You could give me the result. F is 50 hertz for our transmission line. F is definitely 50 hertz. So if you just put down the 50 hertz, give me the calculated value of XC.
Sir, it's 5
Sir, 544.
into 10 to the power minus 4.
5.44 into 10 to the power minus 4.
Yes, sir.
In the 10 to the minus 3.
Minus 4, sir.
Make it 3. Make it 3. Convert it to the minus 3. Give me the milli amount or micro amount.
So 0.5 into 10 to the power minus 3.
0.5 milliohm. Is it correct?
Yes, sir. Yes, sir.
Are you sure about that? What are you saying?
Sir, আমার sir 544.12.
স্যার আমারও স্যার এই 44.118
Have you considered the micro amount?
জি স্যার মাইক্রো
জি
অ্যামাউন্টটা
স্যার
স্যার
মাইক্রো কনসিডার করলে এটা আসে
So what is the answer?
544, sir.
544.11.
5.85 microfarad. If we just take micro 10 to the power minus 6, so if it is going to 3.14 into 50 into 4, this one have been inverted. So I get it 544.
Yes, sir, it's 544.11 microfarad.
This is the wrong answer.
I was doing -3, sir. It's recording reverse.
This much ohm, right? 544.1 to the ohm. So now if we think about the impedance for this one, the impedance will be R minus JX2. So for a transmission line, if the resistance of the transmission line is suppose 0.1 ohm per meter, 0.1 ohm per meter, if I just consider it, then what will be the total resistance of the transmission line? Anyone? 0.1 ohm per meter? No. Take it per kilometer. 0.1 ohm per kilometer. If we just take it, so 0.1 multiplied by 1200 is how much? It is basically 120, right? 120. So ultimately, what we are getting, we're getting the transmission line impedance is 120 minus 544.12 J ohm. Do you understand these things?
Yes, sir.
Yes, sir.
The transmission line, this is definitely a significant amount of impedance. When huge amount of voltage is applied, voltage divided by impedance will be the current, and due to this impedance, some power will be lost. So this will be the significance. Okay. Now the math number 9.12, what it is asking for, a three-phase overhead transmission line has its conductor arranged at the corners of an equilateral triangle of 2 meter side. Calculate the capacitance of each conductor per kilometer, given that the diameter of each conductor is 1.25 centimeters. Okay. So what it is saying, calculate the capacitance of each line conductor per kilometer, given that the diameter is 1.25. So conductor radius is this much, 0.625 centimeter. Spacing of this conductor is 200 centimeters. So capacitance of each line, actually it is not saying that find out the capacitance of all the cables. It is just saying that find out the capacitance of each line. So for each line, what we should do, 2 pi epsilon naught divided by ln D divided by R. So here D is definitely 200. If we just put down all those values, the result is becoming 0.0096 microfarad per kilometer. So I hope you can understand this math extremely easily. Any question for this one?
No, sir.
Okay. Now let's talk about the 9.13. What it is saying that a three-phase 50 hertz. Just wait a second, please. I have a phone call to receive. Huh? Please wait a second. Well, I'm sorry, my father called me. Are you hearing me now?
Yes,
Yes,
sir.
sir.
My father, so I have to receive the call. Okay. So the thing is, it is saying that a three-phase 50 hertz 66 kV overhead line, in this kind of line, conductors are placed in a horizontal plane as shown in figure 9.26. The conductor diameter is 1.25 centimeter. Okay, the diameter of each conductor is 1.25 centimeter. If the line length is 100 kilometer, calculate the capacitance per phase, charging current per phase, assuming complete transposition of the line. Transposition means this one. Okay, that is after a certain distance, it is transposed. Okay, anyway. So what it is saying, the arrangement is such that the distance between two wire is 2 meter. This is 2 meter. That is 2.5 meter. Ultimately, it is 4.5 meter. If you just consider the phase A, that's the phase B, that's the phase C, or cable A, cable B, cable C. Then once again, just like the last class, what we have learned, what is the equivalent or equilateral distance? The equilateral distance can be calculated, which is d1, d2, d3, and root 3 of these things, right? Root 3 of d1, d2, d3. So root 3 of d1, d2, d3 is becoming 2.82 meter. The conductor radius is 0.625. Conductor spacing is 282 centimeter. Okay, the spacing of each conductor is first one is 2.82. From where it is getting 2.82? Conductor spacing is how much? Why it is 2.82? Someone is sorry. It is the equilateral spacing, right? The equilateral spacing, that is on an average, equilateral spacing between these three are considered as 2.82. So ultimately what we get, line to neutral capacitance. The capacitance between transmission line and the neutral wire should be 2 pi epsilon naught divided by ln something something. This is the result. But line to neutral capacitance for 100 kilometer should be multiplied by 100. Okay. Now next one is charging current. So charging current, how to calculate? The current that is flowing through this capacitor or the charging capacitor in the charging phase. The current should be how much? You know, the voltage per phase divided by the reactance value. Voltage per phase divided by reactance. So this is the line voltage given, 66 kV. Phase voltage we need to consider. So you know, line voltage is root 3 times of the phase voltage. So phase voltage is definitely 66,000 divided by root 3. And XC is 1 by twice by FC. XC is 1 by twice by FC. 1 by twice by FC. So when it goes upper side, it is becoming twice by FC. So when we just put down all the results, all the answers, all the values, we get the result as 10.9 ampere. So do you understand the meaning of this calculation?
Yes, sir.
স্যার সেকেন্ড পার্টটা স্যার একবার বলবেন, বুঝিয়ে স্যার।
Charging current?
জি স্যার।
Current in the capacitive circuit, if I want to write down in terms of the AC, it must be V phase. That means the phase voltage divided with phase capacity, phase impedance, right? Or you can just consider the. Just wait a second. Let me clarify. So there are 2 points. First of all, if we think about the impedance Z is equal to R minus JXC, is not it? But the question is asking for the charging current. So this charging current can be found out considering the XC only. Once again, when we are considering the impedance, the normal current, the current flowing through the conductor or current should be I is equals to V phase divided by Z phase. Am I clear? I hope you can understand this thing. But the question is asking for charging current. Charging current is basically not considering the resistance. It is only about the reactive current because of the capacitor. So when we just consider the capacitor and the capacitive effect, the charging current value, you can just say this is I charging. So this charging current value should be phase voltage divided by the XC. Okay, V phase divided by XC. Now the V phase, how to calculate the V phase? We know the line voltage. So we can just say line voltage divided by root 3 is the phase voltage. Is not it? So phase voltage is line voltage divided by root 3. What is XC? XC is, we know, 1 by 2 pi FC. Now, as because it is 1 by 2 pi FC, when it goes upward, what would be the result? 66,000 divided by root 3 multiplied by 2 pi FC. Now put down the value of 2 pi FC, 66K, and the result is becoming 10.9. Does it make sense?
Yes, sir.
Any other question?
No, sir.
So now let's check this one. Calculate the capacitance of a 100-kilometer long. Again, a phone came from the office. Just a second. So, sorry. So what I'm talking? I'm talking about the example 9.14. The question is calculate the capacitance of a 100-kilometer long three-phase 50 Hertz overhead transmission line consisting 3 conductors, each of diameter 2 centimeter and space 2.5 meters at corners of equilateral triangle. So what does it mean? এটা যদি এরকম কন্ডিশনে থাকে, what's the difference here? 2.5 meter. What's the difference? 2.5 meter. And what's the difference? 2.5 meter. Right? So what is the diameter of each cable? 22 centimeter. So what is the radius? Definitely 1 centimeter, right? Okay. And the equilateral distance. The equilateral distance can be calculated like this one. 2.5 into 2.5 into 2.5 and 3. So what would be the result? Basically 2.5, right? 2.5 meter, or we can just say 250 centimeter. So equilateral distance or equilateral spacing is 250. Radius of conductor is 1 centimeter. Capacitance of each conductor to neutral. If we just do the calculation, the result is this much. Now for the capacitance of 100-kilometer long transmission line, I hope you can find out the result extremely easily. Any question?
No, sir.
No, sir. Who can tell me, sir, why the equilateral spacing is taken over here? What is the reason of equilateral spacing? Who can tell me?
Sir, triangle এই জন্য স্যার।
Equilateral spacing টা কেন নিচ্ছে? কেন এখানে আগেরটা থেকে triangle ছিল? Was there a triangle over here?
No, sir.
Then why you are considering the equilateral spacing? So that we are considering equilateral spacing because we are thinking of cable 1 We're thinking of the cable A, and what is the capacitive effect on B, and what is the capacitive effect on C. Similarly, when we think about the current in the B, capacitive effect should be held in A and C. When the current will go through the C, then effect will be happen in B and C. So therefore, to make it simple, to make it more easy, the equilateral spacing sensor. Okay. So the equilateral spacing between them, it is not the average. It is not that it is the average distance we are talking of. It is not the average distance, or it is called the equilateral spacing. Okay. Okay. Now this one, I hope you can do it very easily. What it is saying, a three-phase 132 kV overhead line has conductors placed in a horizontal plane 4 meter apart. What's the difference? 4 meter between them. So if the line length is 100 kilometer, calculate the charging current per phase, assuming complete transposition. So the phase A, B, C, in between A and B 4 meter, B and C 4 meter, and C and A, that could be 8 meter, right? So what will be the equilateral spacing? Equilateral spacing will be root 3 times 4 into 4 into 8. If we just do the calculation, I hope the result will become 5.04. Okay,
স্যার এখানে
5.04.
যদি ওয়্যার যদি 4টা থাকে তাহলে কি স্যার রুট ওভার 4 হবে?
4টা হলে 4 হতো না।
ওখানে যে কিউবের জায়গায় কি স্যার 4 হবে?
4 হবে কিনা সেটা তো কোয়েশ্চেন হচ্ছে, ওই যে তোমরা কি বলে লাস্ট ক্লাস আমরা দেখলাম না, মনে নাই? কয়েকটা অপশনস ছিল, কি কি হতে পারে। বেসিক্যালি তোমার তো যে কোনো ধরনের হলেই হবে না, তাই না? Either it could be single phase 2 valve line, or it could be 3 phase 4 valve line. তো এই ধরনের হিসাবগুলো যেগুলো মানে রিয়েল টাইম ইউজ হয়, সেগুলোর ইকুইল্যাটারাল স্পেসিং কোনটার জন্য কত হবে, উই হ্যাভ অলরেডি ফাউন্ড আউট দ্য ফর্মুলা। আমরা লাস্ট ক্লাসে একটু দেখেছিলাম, মনে আছে? ফর্মুলা আমরা ডিরাইভ করিনি, আগে এগুলো ডিরাইভ করা হতো। নাও উই হ্যাভ নট ডিরাইভ দেম, whether we will use them directly. তো এটা যেহেতু ডিরেক্টলি ইউজ করব, যেগুলো আমাদের রিয়েল টাইমে লাগে, সেই ফর্মুলা গুলো ডেফিনেটলি those will be given to you. So after finding the equilateral distance 5.04, now capacitance of each conductor to neutral is this much. For 100 kilometer long transmission line, this should be this much. Phase voltage, this much. Phase current or charging current per phase. If we just put down the values, the result is becoming 21.18 ampere. Okay, so that is also similar to the previous one. Any question from here?
No, sir.
No, sir.
Sure.
Yes, sir.
Now do one thing. If you're certain about that, do one thing. We have done a math previously for the quiz number 1. The same question is here. You just consider your data. That is the same question, same everything, just calculate the capacitance. Can you do that? Do you understand my point?
Yes, sir. Yes, sir.
Do you understand?
জি স্যার, বুঝতে পারছি স্যার।
Which question you should do, but you need to find out the capacitance now. So please do it. Everyone, please do it. Do it with your own values. With your own values means values coming out from your ID. Values coming up from the ID. can please do it? You can please do it. And then,
Yes, sir.
then what you need to do, you need to submit a screenshot or a picture of that thing here in the discussion channel. The discussion.
হ্যালো স্যার স্যার একটা কোশ্চেন স্যার করব
Correct.
স্যার আমি স্যার কুইজে স্যার হচ্ছে যে এভাবে স্যার ম্যাথটা করলাম স্যার আমার আইডি দিয়ে স্যার সেম ওয়ে থেকে স্যার এই ম্যাথটা করব
তারপর ধরে কি বুঝাচ্ছি?
স্যার মানে কলটা স্যার কেটে কেটে আসতেছিল স্যার মানে আমার এদিকে বৃষ্টি হচ্ছে এই জন্য স্যার শুনতে পাইনি প্রপারলি
Hurry up, hurry up, hurry up. কথাটা ভাগ করবা। তাড়াতাড়ি করো। Are you observing everyone? You can submit up to 340. তো এখানে তো সাবমিশন টাইম উঠবেই, আমি এখান থেকে বুঝতে পারবো কে কে টাইম মতো সাবমিট করতে পেরেছে আর কে করতে পারেনি। ঠিক আছে, প্লিজ সাবমিট। নিজেরা পড়ো, পড়ে সাবমিট করো।
স্যার কোশ্চেনটা
আমি বুঝতে পারিনি কি বললাম।
কোশ্চেনটা ওইখানে আরেকবার দেখতে চাচ্ছি।
কিসের কোশ্চেন দেখতে পাচ্ছ? কোশ্চেন কোথায় তুমি পাচ্ছ? ক্লাসের মধ্যে কি আদৌ থাকো? Hurry up, hurry up. Okay, so our time of the class has been ended. So let's end the class for everyone. Okay? বুঝিনি কি?
স্যার শেষ স্যার লিভ নিব
Like, আরে বাপরে, এত রিফ্লেকশন কেন? Hello?
ইয়েস স্যার
What's the question?
স্যার সাবমিট করার পর কি স্যার লিভ নিব নাকি এটা জিজ্ঞেস করুন।
হ্যাঁ, এখনই ক্লোজ করে দিচ্ছি মিটিংটা। Basically, our class is done, so we are closing the